So this section covers parametric equations and inverses. When we think about standard equations, we usually think of an XY variable. And what parametric equations does is it introduces a third variable. So both of the original variables are then dependent on something else. A good example of this is like time. So if your X variable is dependent on time and your Y variable is dependent on time, then you have these two kind of separate equations that make up your XY values. And so your ordered pairs look a little bit different. You actually take your T value and you plug that into each equation to then get the points of your XY for your parametric equation. And so for this example here, they want you to use -3 all the way to +3 for your T value. And you just simply plug it in, -3 plugged into the X function. Um, gives you a 6, -2 plugged in gives you a 1, and so on and so forth. Then you do the same thing with those values for the y function, t plus 1. You plug in your -3 to your +3 into your t plus 1 function, and you get those. And so now your xy's are based off of a third variable. And you don't actually graph that third variable. You graph your xy's just like you would. And so you have your xy. 6, -2, your xy, and you go all the way down and you'll see you have this, what looks like a sideways parabola for this particular one. Doesn't always work that way, but this one did. And this is your parametric equation. So this equation here, um, made up of those two, results in this particular graph. And so if you were to graph this, they have given you your range here for your t, and you're just going to plug those in. We're going to say, well, if I want to find my x's, I'm going to plug in those values from -2 to +2 and get my x value. And then to get my y value, I'm going to plug in those same into the 2t plus 1. And you will get your XY range and your function graphed accordingly. And so let's talk about inverse relations. So then inverse relations actually switch your X and Y. So if a relation contains the ordered pair AB, then the inverse contains the ordered pair BA. So literally in an inverse, it flips your X and Y. You can tell if you have a function with a horizontal line test, because when you flip that X and Y, what you actually do is you actually flip it across the Y equals X line. And so instead of drawing a vertical line and doing that test, you can actually draw a horizontal line and say, is my inverse going to give me a function if it flips across that line of symmetry there? And so to find the inverse, there's just some basic steps. So remember that your f of x is your y value. And so when I'm finding the inverse to this function, so I'm going to write it like this: y equals 1/3 x plus 1. My first step is to switch that x and y. So we're going to switch the x and the y. Literally write it, instead of a y value, we're going to write an x. And instead of the x value, we're going to write a y. From there, we are then going to solve for y. And so I'm going to do just like I would if I were solving this equation for that variable. I'm going to subtract that 1, x minus 1 equals 1/3 y, and then I'm going to multiply by the 3. So y equals 3x minus 3. My last step is to rewrite that y back into function notation. So we're going to rewrite this in function notation. However, we're going to use an indicator of a -1 on that function that we have found the inverse, not the original. So you don't want to write just f of x. This indicates the original function up here. We want to put this little -1 right here. That means I found the inverse of that function. And then that would be my answer for this particular function. So to find the inverse, I would, again, s- write this as a y value instead of f of x. we're going to switch our x and y. The x and y, you're just solving for that y value. So again, you're going to just do what you always would do for these. Typically, that negative you're going to want to pop to the top there. If you want it in a linear form, you can write it like this. And then remember, we're going to change out that y. So we're going to say f to the negative 1 equals negative 1/4 x plus 3 halves. And then this number 9 here is just wanting us to say, nope, we will not have a function when we take the inverse here. We will have an inverse, but it will not actually be a function because that line test does not work. Now, to verify inverses, you're going to use composite. And so composite functions, remember, you put one inside the other. And it's really simple. It doesn't matter which order you do it in. You'll notice that they have f of g or g of f. But what matters is that when you do the inverse or do the composite of inverses, you will always have your final answer as just the variable that is an input variable, in this case, just the x. So if I were to do check to see if these were inverses, it doesn't matter what order. So I'm going to take that f function, I'm going to plug in my g function and add 1. And then I'm going to just simplify it, distribute. I would get x minus 1 plus 1. When I simplify, I get x. This means that yes, f of x and g of x are inverses. If I got anything else, let's say I got x plus 1, let's say I got 2x, it would be no, they are not inverses of each other.